that are revolutionizing our world and touching our lives. And in this hour, we're going to bring on Dr. Robert Zubrin, who's famous for being the man for decades who's been talking about going to the planet Mars. He's a former aerospace engineer with Lockheed and Martin Marietta. He's worked out the mathematics, the mechanics, the science of what it would take to begin the process of going to Mars and maybe even terraforming Mars, that is, making Mars more Earth-like. He's the founder of the Mars Society, got a PhD in nuclear engineering from the University of Washington. And today we're going to talk about going to Mars. What about the dangers? What about the potential? What about the benefits of going to the red planet? Well, once again, in this hour, we're talking about the planet Mars. What would it take to begin the process of going to Mars, given the fact that we have not one, but two major private companies that have staked out a timetable to go to the planet Mars. We have SpaceX and Elon Musk, its founder. Elon Musk says 2024. Write that down on your calendar. That's when we begin to put humans on the planet Mars. And he has big plans for Mars. He envisions a fleet of 1,000 rockets with 100 passengers each, creating the first city on Mars. Now, normally, anyone who talks like this is considered a lunatic, crazy, out of his mind, except this guy is a billionaire. He's already made history by creating the first reusable rocket, and he could practically fund a manned mission to Mars by himself. All he has to do is take out his checkbook and write a check for $10 billion, and off we go to the planet Mars. And not to be outdone, Boeing, which made the boosters for the Saturn rocket, they're in the game too. They actually want to beat Elon Musk. And they have stated that the first rocket to touch down on Mars with humans aboard will be a rocket made by Boeing. So this has now raised the stakes for going to Mars. And President Barack Obama even stated last year that in the 2030s, sometime in the 2030s, he says that he will be there to watch humans walk on the surface of the red planet. But what about all the problems about radiation, about micrometeorites, about weightlessness? We'll talk about all that with Dr. Robert Zubrin, founder of the Mars Society, one of the leading figures pushing us to go and walk on the surface of the red planet. His book is called The Case for Mars. Find out what a former aerospace engineer thinks about when he talks about one day flourishing on Mars, creating the first cities on the red planet.
This is Science Fantastic. The most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about a pioneer who for decades has been talking about going to the planet Mars. At first, it seemed preposterous, too expensive. People thought that, well, Mars is simply too far out, too expensive, and it's not on NASA's agenda. Well, have times changed? Now we have not one, but two companies that are, in some sense, competing to be the first to be on Mars. So with us today is Dr. Robert Zubrin, former he's still an aerospace engineer. He's worked for Martin Marietta and Lockheed Martin, got his PhD in nuclear engineering from the University of Washington, authored a book called The Case for Mars, and in 1998, he helped to found the Mars Society. So, Dr. Zubrin, glad you could be on Science Fantastic.
Thanks for inviting me.
Okay, well, the first question that we always ask our guests is, how did you, as a youth, way back then, how did you first get interested in science?
Well, for me, it was Sputnik. I was 5 when Sputnik flew, and while to the adults it may have been a terrifying event because it meant the Russians could hit us, to me, as a child who was already reading science fiction, it was absolutely exhilarating. I was over the top because what this meant was that these stories that I was reading about the spacefaring future were going to be real, and I wanted to become part of that. So, I was a child of Sputnik and Apollo, and I went out and built rockets, and my father got me a telescope, and I read everything I could about science and astronomy and the planets and rocketry, and I was on board. And we were going to the moon by 1970. It was going to be Mars by 1980, Saturn by 1990, Alpha Centauri by the year 2000. We were moving out, and I wanted to be part of it. And, of course, only the first milestone in that program was achieved. We did get to the moon by 1970. NASA did have a serious plan to reach Mars by 1981, but it was aborted by the Nixon administration. And in a way, that was one of the great disappointments of my life. For a while, I kind of pulled back, and I was just decided I'll be a science teacher, and I was for a number of years, and that is a noble profession. But the dream that motivated me was still out there. And so in the 80s, I decided I wasn't going to give it up. I went back to graduate school. I became an engineer, and eventually I got a job with Martin Marietta doing preliminary design of interplanetary missions.
And speaking about your youth, were there any particular science fiction books or authors that mesmerized you? There was the John Carter of Mars series by Edgar Rice Burroughs, Isaac Asimov, Arthur C. Clarke. Any particular book that stands out in your memory?
Well, I would say Clarke and Heinlein. Mm-hmm. Those two had the greatest influence on me. I did like the John Carter books, and they were much less hard science fiction, but they did make a fundamental point, which is that this isn't the only world, that there could be other worlds out there, which Burroughs painted in great detail. But I would say I was more of a Heinlein and Clarke kid.
Okay. And in some sense, do you feel vindicated? Because so many years you were in the so-called wilderness talking about going to Mars when other people would snicker and laugh and simply dismiss Mars. In some sense, do you feel vindicated that there's so much interest in Mars now?
Okay. Well, we didn't call ourselves the wilderness. We called ourselves the Mars Underground. Okay. And yes, we've come up. And it really shows the power of ideas because we have pushed this idea, and what ideas can do is recruit to their banner all kinds of people, including very capable people and powerful people, such as, for example, Elon Musk and Jeff Bezos have now, decided to make this their calling. And so great resources have been recruited to this cause, and this is going to continue to happen. There'll be more of these people that are recruited, and that's why we're going to win.
Okay, well, let's get right into the whole substance of the new Renaissance interest in Mars. You mentioned Elon Musk of SpaceX. He's a billionaire, and he raised quite a few eyebrows last week when he laid out a very ambitious plan to send people to Mars by 2024 with a modified Falcon rocket. He talked about perhaps even having 1,000 rockets with 100 passengers each. Of course, that's further down the line. So let's now assess these proposals. What are your thoughts about the proposal of Elon Musk and SpaceX and the proposal of Boeing?
Okay, well, I like the spirit of Musk's proposal, the boldness of it. I think he's going to have to take, courage and condition it with practical wisdom to make it a success. I think it's a bit grandiose, but I do agree that this is doable within a decade or so. And I did write a detailed critique of Musk's Mars colonization proposal, showing how it could be made more practical by certain modifications and basically reduce its cost by about a factor of 10 and bring it into the reality. So Musk likes to start with a really dramatic proposal, but he's a smart guy and he knows how to eventually listen to people and modify his ideas to make them work. And I think Musk's on the right track, and I think his proposal needs some more technical work and refinement, but it could be done. As far as the Boeing and Lockheed proposals are concerned, I think they're too timid, and that's a much bigger problem because, like the Lockheed proposal, which I'm well acquainted with, which doesn't even go to the surface of Mars. They go to Mars orbit, and then they operate robots on the surface of Mars. And if you're going to do that, why even go? You could operate robots on the surface of Mars from Earth. And so, if you're going to go to Mars, you need to go to Mars. And but Musk is basically Sputniking the mainline aerospace industry. He's showing that he can do things in 1/10 the cost and 1/3 the time that they have come to accept, and it's setting a new standard. He's even showing that he can do stuff that they had deemed impossible, like reusable boosters. So there's a new kid on the block. There's a new standard being set, and these older companies are going to have to step up their game. And actually, I think they will, because once again, I used to work at Lockheed. I know there's a lot of very good people there that are anxious to embrace the challenge that Musk is presenting them. And while management may be a little hesitant, they're going to have no choice.
Now, some people, when they size up Musk, say that, well, he represents private enterprise, not the lumbering bureaucracy of NASA, but slim and more risk-taking. So what do you think about the new style coming in that is going to be less government bureaucracy and less bureaucrats and more entrepreneurs who want to get things done rapidly and cheaply? What are your thoughts?
Well, I think it's a very positive development. When I first proposed my Mars Direct plan, which was a dramatically cheaper and quicker way of getting to Mars than what had been generally being considered at that time, I was approached by some people who had a lot of experience with NASA and then said, look, they're not going to want this. The last thing they want is to get to Mars in 10 years. They want to, make this their career, and NASA has a way of not spending money to do things, but doing things in order to spend money. Now, with the case of Musk, he's partially funded by NASA, but he's also substantially funded from himself. And so he's spending his money like it's his own. And, you and I, we don't do things in order to spend money. We spend money in order to do things. And that's a much more productive way to get things done. And that is why Musk can do things at 1/10 the cost that the NASA program typically involved, because he is trying to do them quickly and cheaply. He understands that in aerospace, cost is people times time. And so doing things aggressively and quickly doesn't increase cost, it reduces cost.
Okay, now let's talk about the rival proposal that was mentioned. Boeing says that they're going to beat Musk, that they will be the first ones to put men on Mars. And they have, of course, the SLS booster. And the SLS booster is the workhorse of NASA for missions to Mars. So what are your thoughts? Is there going to be a race between these two, or do you think one has an advantage over the other? Or do you think it's a good thing that we have a little competition going to Mars?
Well, I think it's a great thing that there's competition. But I think the whole SLS thing is going to have to step up its game because, look, the SLS is a leftover from the George Bush's lunar initiative that required a heavy lift booster called an Ares. And when Obama killed that program, the various congressional factions that had the Ares booster, which is what it was then called, program in their district, fought to retain it, and they succeeded in preserving it. So you have a booster program which is by itself. It's as if someone had canceled the Apollo program in the mid-'60s, but the people building the Saturn V had managed to hold on. And so we had a program building Saturn V rockets without the command module, the lunar excursion module, all the stuff required to actually go to the moon. So we're left with a giant rocket and nothing for it to launch. That is essentially the situation we're in now. In order to make the SLS program rational, the rest of the hardware set required to do the Mars mission has to be built essentially at the same time. Otherwise, you're left with a booster that you can do, 4th of July displays with, but nothing else. And there's only so long the taxpayers will pay to maintain such a capability without any utility. So this is a problem. And Boeing and Lockheed need to go to NASA and say, look, this doesn't make sense just building a booster with nothing for it to launch. What we need is an end-to-end program. Here's all the pieces necessary to execute Mars missions. Yes, the booster is one of the pieces. We need the other pieces, and then this country will be going somewhere in space. But we can't just have programs that are there in order basically to send money into various congressional districts that have an interest in those programs.
Okay, now what are your thoughts about this whole idea of shooting not just for a manned mission to Mars, but to create a city of a population up to 1 million people? Musk is talking about 1,000 rockets with 100 passengers per rocket to jumpstart the creation of the first city on Mars. Do you think that's a little bit overly ambitious, or do you think it's doable given several decades of practice and cost cutting? What are your thoughts?
Well, I believe Mars will be settled, but it will be done in a more organic way. It's not going to be settled by us having a fleet of 1,000 ships with 100 people in each ship and all going at once. The way it'll happen is this: is first we send our first explorers to Mars, and they find the best place to put a permanent base. And then we'll have a base that'll have 20, 30, 40, 50 people in it, and it will be enormously valuable to whoever's sponsoring that base, whether it's a corporation or the government or the United Nations, to have people who are at the base stay there for longer tours, because the main expense is actually sending them back and forth. They don't really cost much once they're there. So instead of just spending 2 years on Mars, they'll spend 4 years, 6 years. So people become lifers on Mars, and they'll form relationships, and children will be born on Mars. And once you have that, then you're going to start creating institutions like schools and so forth that you need to turn a base into an actual society. And so the base will turn into a settlement. And one of the things that's going to be going on in the base at the settlement is developing the technologies required to turn Martian raw materials into resources. Okay, I actually don't believe there's any such thing as a natural resource. There's only natural raw materials. It's human ingenuity that turns raw materials into resources. So Mars has got all this red sand. Well, with the right technology, that's iron. That's steel. Okay, Mars has got subsurface geothermal heat. With the right technology, that's power and water. It's got CO2 in water. With the right technology, that's plants, that's agriculture. So if we develop the technologies that allow human beings to be self-sufficient on Mars, then Mars becomes a place that we can settle. And then increasing numbers of people are going to go there. And, of course, during all of this, as we're there for a longer period of time, we're going to develop more efficient technologies.
Okay, Robert, we're going to have to take a short commercial break. And after the break, we're going to talk about, first of all, getting to Mars. How long is it going to take? What about weightlessness? What about radiation? And then once we're there, we have to think about the terraforming process.
Science Fantastic with Professor Michio Kaku. Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about the planet Mars. We're not talking about a pie in the sky. We're not talking about science fiction. We are talking to an aerospace engineer who's been a pioneer for decades, talking about how to get to the planet Mars. With us today is Dr. Robert Zubrin. He has a Ph.D. in nuclear engineering from the University of Washington. He's worked at Lockheed. He's worked at Martin Marietta. And he wrote the book, The Case for Mars. And he's a founder of the Mars Society. And we are talking about going to Mars, settling Mars, and one day perhaps even terraforming Mars. Well, Robert, where we last left off, we were talking about the proposals of Elon Musk and Boeing. Apparently some kind of rivalry is being set up to be the first to get to Mars. But let's talk about getting to Mars. First of all, how long will it take to get to the planet Mars? And recently we had two astronauts. One twin went into orbit for almost a year, and he came down, and we're analyzing the difference in the biology of these two astronauts to see what prolonged weightlessness will do to the human body. So tell us a little bit about what it would take for humans to get to the Mars, how long, and what happens on the way.
Okay. Well, first of all, to develop the technology or the hardware to go to Mars, I think will take about 8 to 10 years, okay? But in terms of the actual trip, it can be done in 6 months using current-day technology. And, in fact, we've sent probes to Mars that left here in April and got there in October. So what Kelly did in spending a year in space actually was spending a longer period of time in zero gravity, almost twice as long as would be needed for a person traveling to Mars. Now, furthermore, I actually believe that we should not go to Mars in zero gravity at all, that we should rotate the spacecraft and create artificial gravity for the crew, because virtually all of the deleterious effects that we've seen in spaceflight have been due to zero gravity. People like to make a big deal about radiation effects. We have actually not seen any radiological health effects in space, but we have seen zero gravity health effects in abundance, weakening of bones and muscles, even effects on vision, sometimes nausea. These are all zero gravity effects. And while they are endurable, and in fact the standard tour on the space station is 6 months, so every astronaut practically who goes to the space station does 6 months in zero gravity, which is the time it takes to fly to Mars. If you want to have people doing field exploration, you want them in top physical condition, not just having survived the trip. And therefore, I think gravity is the way to go.
Okay. Now, recently there was a report coming out of the University of California where they analyzed mice and they subjected mice to radiation in the laboratory comparable to what they may get in deep space. And
That's not accurate.
Yeah. Could you comment on that study or studies like that?
While the total dose was only about half again as large as astronauts would receive on the way to Mars, the dose rate that was used in those experiments was 40,000 times as quick as the dose rate that you would get in space. And this is very important because in toxicology, the rate at which you take in a toxin is extremely critical. You could drink a glass of wine a night for a year, and it would be good for your health. If you drink 365 glasses of wine in a single night, it will kill you. So the UC Irvine study that was done, which announced those results, was not a valid study in terms of relating to radiation effects on astronauts because the dose rate was vastly higher, 40,000 times higher than what astronauts would experience.
Okay, well, let's take a short commercial break. And after the break, we're going to talk about, well, what do astronauts do once they get to Mars? What is the atmosphere like? What is the terrain like? What is it like to be on Mars?
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, we're talking about going to Mars. We're not talking about a pie in the sky. We're talking about a fact that, yes, people are now talking real money. They're talking real booster rockets. They're talking about the real thing, going to Mars, perhaps as early as 2024 or perhaps sometime in the 2030s. With us today is Dr. Robert Zubrin, who's been a pioneer in trying to work out the mechanics, the cost, and publicize the whole journey of going to Mars. He has a PhD in nuclear engineering from the University of Washington. He's the author of the book, The Case for Mars, and he's one of the founders of the Mars Society. So, Robert, let's say you're on Mars now. What is it like to be on an alien planet? The gravity, the weather, the oxygen, or if there is any. What is it like to be on Mars?
Well, I've never done it, but and no one else has either. Mm-hmm. But here's the thing, okay? It's 1/3 gravity of the Earth, which should be pleasant, and it's an advantage because it means that if you're wearing a heavy spacesuit, it won't feel very heavy. Now, of course, the fact that the atmosphere is only 1% as thick as the Earth's and that it's almost all carbon dioxide means that you have to wear a spacesuit. You cannot breathe the Martian air. So there you go. But once again, you are helped by the 1/3 gravity in this respect. Of course, it's a vast unexplored area, and the first people who go to Mars, their primary mission will be exploration to resolve questions of natural science, the question of whether life appears in places where you have the right physical and chemical conditions, because Mars once did have a warm and wet climate in which there's no reason why life could not have appeared. In other words, are the laws of chemistry such that they lead to life where you have the right physical conditions, or is the Earth an example of freak chance? This is what we're going to find out by going to Mars. They're also going to be prospecting for materials that could become Martian resources for Martian base. So there'll be this fascinating problem of field exploration before them. And, the Mars Society actually has a practice Mars base in the desert in Utah, where we practice exploring the desert there in the same manner it would be done on Mars. And our people there actually made a discovery of dinosaur fossils, which has led to the largest find of trove of dinosaur fossils since Dinosaur National Park, or one of the largest find of dinosaur fossils in the world. We discovered it while we were doing exploration in spacesuits in Utah. And, my hope is that someday people will be able to do that on Mars. But contrary to some views of the mission where the main human factors problem is going to be boredom, I think the main human factor problem of the Mars crew will be overwork, because they're going to be in this place where there's going to be so much to do and so much to look for and so much to explore, that if these are the right kind of people who want to get the answers, they're going to drive themselves. And they'll work hard, but it'll be worth it.
Now, some people say that why not use a cave on Mars? A cave would give you shielding instantly. You'd be underground, micrometeorites. You wouldn't have to worry about that. Sandstorms, all the different kinds of extreme conditions on Mars. You wouldn't have to worry if there's a ready-made cave. And there are lava tubes on Mars. But what are your thoughts? Is it going to be like a science fiction, a movie where we have gleaming domes on Mars? Or are we going to start off living in a cave? What are your thoughts?
Well, I think the first people who go to Mars will start off living in their spacecraft, which will be landed on the Martian surface. And they'll probably want to throw a layer of sandbags on the roof of that craft in order to block out most of the cosmic rays and bring them down to a level at which they really represent a minor portion of total mission risk. I think there's some merit to the idea of, once we're on Mars, of looking for caves and installing some habitats in them so that people who are in them will have complete shielding from space radiation. I don't really think micrometeorites are that much of a problem. The Martian atmosphere, as thin as it is thick enough to burn up micrometeorites and shield the people. So the people on Mars are going to be much safer from micrometeorites than, for example, the crew on the space station.
Okay, Robert, we're going to take another short commercial break, and after the break, we're going to continue our discussion about Mars and terraforming the red planet. One day, perhaps, we will be on Mars.
Science Fantastic with Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, we are talking about going to Mars, the real thing. This is not science fiction anymore. Even President Barack Obama talked about going to Mars sometime in the 2030s. And we even have Elon Musk, founder of SpaceX, talking about landing on Mars by 2024. With us today is Dr. Robert Zubrin, who's been a pioneer in the subject for decades. He's the co-founder of the Mars Society, which he started in 1998. He has a PhD in nuclear engineering from the University of Washington. He's an aerospace engineer. He's worked for Martin Marietta and Lockheed. And we are talking about going to Mars. Well, some people ask the question, why go to Mars if we're going to go there and come back, like the moon? But people are not talking about a sustainable presence on Mars, which means, of course, we have to create at some point something resembling a settlement, maybe something like a city, but it's cold on Mars, and the atmosphere is not breathable. So the question is, how do we begin the process of making Mars more Earth-like? What are your thoughts?
Well, it is the nature of life to take barren environments and transform them into places that are friendly for the development and propagation of life. That, in a nutshell, is the history of life on Earth. Life has terraformed the Earth. The original Earth had no oxygen in its atmosphere. It is life that put the oxygen in the atmosphere. The original Earth had no soil on the continents. It is symbiotic communities of plants and animals that created the soil on the continents, and then were able to move inland from the shores, up the plains, up the hills, up the mountains, as high up as as life can go, it goes. And no sooner does any dead place appear on the Earth, like a Polynesian island coming out of the Pacific, that life comes over and makes it lush. So I think we're going to do that with Mars. Now, in terms of the specifics, I think we're going to terraform Mars the same way we're terraforming Earth right now. That is with greenhouse gases. We are currently warming the Earth. Some people are quite concerned about that, but in the case of Mars, it's absolutely what the planet needs. And we know how to make greenhouse gases that are much more potent than carbon dioxide as greenhousing agents. And if the Martian colonists wanted to warm that planet up, we know how to do it.
Okay, now there's been a number of proposals in the literature. Let me just mention a few of them, and you can shoot them down or say that they are reasonable. One possibility is to deflect comets. So they orbit around Mars and burn up in the atmosphere. Comets are mainly made out of water. So why not deflect a comet and it burns up in the atmosphere? Another proposal is algae. Why not genetically engineer a super algae that can proliferate in the first lakes that are beginning to form on Mars? And then we have Elon Musk's proposal of detonating hydrogen warheads above ground so there's no fallout. But jump-starting this whole process using nuclear weapons. So what are your thoughts, and, how do you size up some of these proposals?
Well, the first and third you need involve crashing comets into Mars or bombing Mars. I don't think are credible because the Mars terraforming project is going to be undertaken by people living on Mars. It's going to be done by and for the Martians. They're the only people that are going to have sufficient interest in such a project to exert the very large effort that will be needed to do it. And either of these methods, in particular the comet collision method, involves significant range safety problems. So for the same reason that we don't dig canals on Earth with nuclear weapons or clear forests with asteroidal impacts, I don't think that's how the Martians are going to terraform their planet. Now, I think the idea of genetically engineering algae or other microorganisms to do something, I think that's quite interesting, and that may be well how it's done. What you're basically talking about with microorganisms are self-replicating nanomachines, and if you could have the right one that does what you want it to do, that could be a tremendously effective way of terraforming Mars. That is sort of how Carl Sagan, way back in the 60s, postulated terraforming Venus by deploying designer microorganisms, photosynthetic organisms in its atmosphere to get rid of the CO2 and cool the planet that way. There's questions. That's a harder thing to do than Mars, which has got a solid surface and is only a bit off, as it were, from habitable conditions, compared to, say, Venus. Okay. And if we went to Mars and, for instance, set up chemical factories that produce fluorocarbon gases that warm the planet and cause the water to start to melt, then perhaps we could let loose photosynthetic organisms of these kind, maybe some that release methane, which is a strong greenhouse gas. It would warm the planet even more. So a combination of physical chemical means and biological means, this is how it could be done, and I think it's how it will be done.
Okay, now, some people write, in fact, in your writings as well, talking about a tipping point. That is, if the surface of Mars rises a few degrees centigrade, then the Mars will automatically release greenhouse gases into the atmosphere, which, again, heats up the planet even more, and so it takes off. So the more methane, the more greenhouse gases you put into the atmosphere, the more heating takes place, which creates even more greenhouse gases. So what are your thoughts about a tipping point?
Well, what you're basically talking about is positive feedback, and we see that. That is happens on Mars. Because, for instance, Mars is in an elliptical orbit that gets closer to the sun during the southern summer. And that actually causes some CO2 to come out of the soil, which amplifies the warming effect. Now, whether it will actually have a runaway greenhouse effect or just amplification is a little unclear. Most of the results indicate amplification. But even if there was a runaway greenhouse effect, there's only so much CO2 in the Martian soil.
Okay, Robert, unfortunately, we have run out of time, but it's been a fascinating interview that we've conducted with you. So thank you so much for being on Science Fantastic.
Right. Can I mention one thing? We have a conference coming up
in
California.
Mention
University
it.
of California, Irvine. The next Mars Society conference is September 7th through 10th. And there's information about it at marssociety.org. The public is invited.
Okay, marssociety.org. Write that website down. Once again, this is Dr. Michio Kaku, and this is Science Fantastic. Go to Mars Society on the web and find out more about Dr. Zubrin and going to the planet Mars.
This is Science Fantastic. Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And once again, in this hour, we're going to throw the lines open because this hour is your hour. Well, without further ado, let's now get to the first listener phone call.
Hello, Professor. My question is, can a galaxy be sort of transported through a black hole? As far as a black hole consumes an entire galaxy, will it come out on another side of the black hole?
Well, yes and no. First of all, a galaxy consists of maybe 100 billion stars, at the center of which we usually find a black hole. So you're not going to find a black hole eating up a galaxy. However, black holes will eat up stars for lunch, and they won't even burp. Entire star systems have been gobbled up by black holes, and we see this in outer space with our instruments. But eating a galaxy is too much. It's 100 billion stars. However, the other question is there another side to a black hole? Is a black hole a gateway to a parallel universe? Now, if you take a look at the mathematics of Albert Einstein, first of all, the mathematics predicts that black holes exist. We see them in outer space. They obey the equations of Einstein. But then the question is, what happens if the black hole is spinning? If the black hole is spinning, it doesn't collapse into a dot at all. It collapses into a ring called the Kerr metric. The ring has tremendous force, power, and centrifugal force. The centrifugal force of the ring prevents it from collapsing. In other words, you will not die when you go through a rapidly spinning black hole. In fact, you'll go to the other side, just like Alice going through a ring called the Looking Glass went from Oxford, the countryside of Oxford, all the way to Wonderland. Now, what's wrong or right with this theory? First of all, it is just a theory. The math says there should be a parallel universe on the other side of a black hole. However, quantum physicists say not so fast. These gateways, these wormholes, may be unstable. In fact, if you watch Star Trek, they often talk about wormholes, and the key thing is, are they stable? Will they contract as you're going through them and cut you in half? That'd be a horrible scenario. And the answer to that question is, we don't know. We need a quantum theory of gravity. Einstein's theories are useless when you go through the black hole. Einstein's equations simply blow up as you go through a black hole. We need a higher theory called string theory, which is what I do for a living. That's my day job. I'm the co-founder of string field theory. But the question is, how stable are these, and can string theory calculate the stability of these black holes? Unfortunately, the answer to that is not yet. On Earth, no one is smart enough to solve all the superstring equations to calculate if you can go through the black hole to the other side. Maybe somebody listening to my voice, maybe somebody listening to Science Fantastic is going to finish the theory and calculate whether or not these wormholes are stable so you can go through a black hole to the other side of the galaxy. Maybe someone out there has the answer. Okay, well, let's move right along to the next listener phone call.
Dr. Kaku, this is Mike calling from Kennewick, Washington, and I listen to you pretty regularly on KONA Radio AM. I have a question about genetics. Let's say that you were walking along someplace in Siberia and you ran across the partially decomposed skeleton of a great woolly mammoth. And would it be possible, using today's cloning techniques and genetics, would it be possible to bring one to life and clone a woolly mastodon like we cloned Dolly the sheep? I'd like your thoughts on that. Thank you.
Well, the short answer is yes. That's how fast the science of paleogenetics is taking place. That is sequencing the genome of animals that are extinct. Now, I've actually spoken in Siberia. The government there in Krasnoyarsk has actually invited me to give a talk about the future. Krasnoyarsk, look it up on the map, is in Siberia. And first of all, I noticed that the climate was rather mild. They tell me that because of global warming, things are warming up in Siberia, which is good for agriculture. They love it. And second of all, because the tundra and because the ice is receding in Siberia, animals that died during the Ice Age over 10,000 years ago are coming out of the ice. This is amazing. As the ice recedes in Siberia, as the tundra begins to thaw out, prehistoric animals that have been stable in the ice, frozen in the ice for over 10,000 years, are now beginning to thaw out. In fact, the Discovery Channel even had a special whereby a near complete mammoth was found. The only part of the mammoth that decayed was the top of the skull, but the entire body was near perfectly preserved. A tremendous amount of DNA was available, and scientists looking at different animals have begun to piece together the entire genome of the mammoth. Something that was once considered impossible has now been done. And that is they've been able to sequence the genes of the mammoth. And now at Harvard University, some professors there are saying, well, why not bring back the mammoth? So after the short commercial break, I'll talk about what the steps necessary to begin the process of bringing back animals that died during the last ice age.
This is Science Fantastic. The most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Well, before the break, we had a question from a listener. Can we bring back extinct animals like the mammoth, which died out tens of thousands of years ago? And the answer to that is, in principle, yes. There's a group at Harvard now which has stated that they're looking at the steps necessary to bring back the mammoth. How would you do it? First of all, you would have to sequence the genes of the mammoth, which has been done. And given that DNA sequence, you would have to cut it up and then insert these chunks of DNA into the egg of, let's say, an elephant. The elephant DNA is actually very similar to the mammoth DNA, so you insert snippets of DNA from the mammoth, taken from the mammoth, and put it into an elephant, and then the elephant gives birth to a baby mammoth. So this is incredible. And then, of course, the next question that people ask is, we've also sequenced the genes of the Neanderthal man. So what's to prevent somebody from doing the same thing with a Neanderthal and then inserting the egg into a human so that a woman would give birth to a Neanderthal? Well, in principle, it might be possible, since the complete genome of the Neanderthal has been found by scientists who've analyzed several Neanderthal skeletons. But then you have a moral problem. The scientists at Harvard were the ones who also proposed that possibility. And the question is, what do you do? What do you do with a baby Neanderthal? Do you put it in a zoo? Or do you put it at Harvard, where it becomes a student at Harvard University? There are ethical questions, because the mammoth, if it's brought back to life, will have feelings. It will have thoughts. It may even be able to talk to us to a certain degree. And so where do you put it? In a zoo or in college? Think about that. Okay, well, let's move right along and take the next listener phone call.
My name is Wendy. I'm listening on 8:20 a.m. Tampa. My question is, I am wondering how the dimensions, I believe 11 dimensions of hyperspace, how far scientists have gone theorizing and elaborating on the differences between each of those dimensions, and if they've theorized about different physical laws that pertain in each of those dimensions. Thank you.
Well, the answer is yes. We theorists have spent a tremendous amount of time working out the physics of these various dimensions. But then the next question is, what about testing these theories? And what about perhaps one day accessing these things? That is where we break down. At the present time, we have no physical tests of these higher dimensions. It would take an enormous amount of energy to create a gateway to these other dimensions. But let me explain what has been done. We now believe that there was a multiverse before the Big Bang. So our universe is a bubble. It's expanding. We live on the skin of the bubble. And that's called the Big Bang theory of Einstein. The new theory coming from string theory is that there are other bubbles out there. And these other bubbles can also have big bangs. They can pop into existence, go back into nothingness. They can have a big bang or a big crunch. And these other universes can be in various dimensions, going all the way up to 11. Now, because this is mathematics, we can in principle extract out the physical implications in each universe. And we find that in these other dimensions, the laws of physics are not the same. Now, you know that when we travel to distant parts of the universe with our space probes or different parts of the planet Earth, you hear the same expression. Well, the laws of physics are the same, so we expect to see the same things. We expect to see stars. We expect to see carbon-based, maybe life forms. We expect to see the 100 elements or so that we've been able to analyze in the laboratory. But in string theory, these other universes in various dimensions can have different laws of physics. They could have more subatomic particles than just the electron, the proton, and the particles of the standard model. Or perhaps matter will be unstable. In fact, that's what we find. We usually find that matter is unstable in these other universes, which makes them not very interesting. Our universe is quite stable, and as a consequence, we have life in our universe because it took billions of years to get life off the ground. So each universe has its own physics, coming from a master theory called string theory. So string theory becomes metaphysics. That is, it's the theory of all these lower dimensional universes. Now, believe it or not, there was a science fiction story written by none other than H.G. Wells. I think it was called The Visitor, where he talked about a collision between these various dimensions. There was a vicar, a religious priest, who was hunting one day, and he thought he shot a large bird, but instead he found out that he shot an angel. Well, of course, he was mortified. When he went to find out the object that he had shot from the sky, he found out that, well, it looked like a human with wings. It was an angel. So he was so embarrassed by this that he took the angel home and tried to nurse it back to health again secretly so no one knew. But eventually, the angel became curious about what humanity was like. He said that one day he was flying in his universe, which had different laws of physics, and all of a sudden he saw this man shooting at him, and that's when he fell to earth. Well, this angel begins to inspect humanity, begins to wander in the marketplace, begins to see people interact, and he is not impressed at all. He sees people cheating other people, people lying to each other, the police necessary to arrest criminals who victimize innocent people. So he's not happy at all with the state of humanity. Meanwhile, the poor priest is stuck with an angel in his house, and he doesn't know what to do with him. Well, I won't give away the ending. It has a rather sad ending. But the question is, can that happen? H.G. Wells writes that our universe is like a plane, but it exists with other planes of existence, and so like two parallel sheets of paper, one day they can intersect. The two sheets of paper can intersect, And that's what happened when he was on a hunting trip. For some reason, our dimensional universe intersected with another dimensional universe, and out popped out an angel. Well, is that possible? Well, in principle, yes, but highly, highly unlikely. And what does string theory say about these things? At the present time, not much. String theory predicts these other universes, but we don't have enough firepower to begin the process of going between dimensions, which would require energies comparable to that found in a black hole. And we certainly cannot play with black holes, at least not yet. Okay, let's move right along to the next listener phone call.
Yes, my name is Doug. I live near Anchorage, Alaska, and I listen on KFQD Radio AM. I was wondering, in a lot of the science literature, it says that charged particles come from the sun. Could you explain what all the charged particles are, and could you explain what muons are? Thank you.
Okay, we'll be glad to. First of all, the atom has no electrical charge at all because positive and negative cancel each other. But charged particles can take place when you rip atoms apart. And this could be potentially dangerous because these solar flares, one day a giant solar flare could hit the Earth and charged particles could wipe out communication. We'll talk about the Carrington event after the break. A Carrington event where cosmic rays, cosmic solar flares from space literally wipe out communication on the Earth and hurl us back centuries into the past.
Science Fantastic with Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Now, we had a call that came in just before the break. And that call was, well, what are charged particles from the sun? And, well, what I want to add is, potentially, they could be quite dangerous. So first of all, what is an atom? An atom is a very tiny object such that it has an equal number of positive charges and negative charges. So atoms, for the most part, are neutral. However, when you excite them with energy, like in the sun with tremendous heat, they're ripped apart. And when you rip apart the atom, you get ions, charged particles. Ions can either be positively charged or negatively charged. Positively charged, like protons, for example, or negatively charged, like electrons or muons. Muons or mu mesons are very similar to a heavy version of electrons. They are very similar to the electrical magnetic properties of electrons, except they're much heavier, and they decay down to electrons. Now, a lot of the cosmic rays, a lot of the radiation from the sun that hits our upper atmosphere is in the form of muons. Now, is this dangerous? Well, potentially, yes. Back in 1849, there was a huge, humongous solar flare that erupted on the surface of the sun. It was cataloged by an astronomer called Carrington. He wrote about it. And several hours later, there was a gigantic disruption of telegraph wires. All of a sudden, telegraph wires that had no charge at all sprung into existence all by themselves. Messages were being sent of gibberish on telegraph wires that had no business transmitting telegraph signals. In fact, in Cuba, they saw the northern lights and they saw the lights they could read the newspaper at night with the lights coming from the northern lights in Cuba. Now, when was the last time you saw the northern lights in Cuba strong enough that you could read a newspaper in Cuba at night all by yourself? Incredible. Now, we physicists have figured out that if another Carrington event were to take place now, we would have very little warning, just a few hours worth, and it would wipe out communications on the Earth. First of all, our satellites are not reinforced. They're not shielded against these gigantic solar flares, so telecommunications and the internet would be wiped out. Also, power stations on the Earth also are not shielded correctly. We don't have redundant power systems. As a consequence, power systems would also go out. And very soon, food riots would erupt because people's refrigerators would lose power, and no rescue crews would come in because rescue crews in neighboring cities are also wiped out in terms of electrical power. Radio, television would all be short-circuited by the solar flare, and so you would have society being thrown back 200 years into the past. We had a glimpse of this once in Manhattan where we had a power failure, and in Times Square, people could not use their credit cards. They could not check into their hotels in Manhattan. And as a consequence, there was chaos, absolute chaos at grocery stores, in hotels. People had to sleep in the lobbies of hotels in Manhattan. It was a mess. Think of what would happen if the entire country, the entire Earth, had the same problem. We'd be thrown back 200 years into the past.
This is Science Fantastic. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. This hour is your hour. Okay, moving right along. Let's take the next listener phone call.
Yes, hi. My name is Stephen, and I am calling from Portland, Oregon. I recently read a book by an author named Paul Laviolette. Last name is spelled Laviolettte, and the book is Secrets of Anti-Gravity Propulsion, Tesla, Unidentified Flying Objects, and Classified Aerospace Technology. In that book, the author talks about two types of technology. One of them is Searle Effects Disk by John Searle, Searle, and that person used magnets in a circular formation, and anyway, created something called a Searle Effects generator or a magnetic energy converter. I'd like to hear you comment on that if you have read that book or familiar with John Searle and his work. And also there's another part in there that talks about gravitic technology or electrostatic energy fields that are distorted with dielectrics to create gravity wells or gravity sinks. All this is involved with gravity propulsion or anti-gravity propulsion. And there's a series of patents on the back, about 49 of them. This all occurred in the 40s and 50s and 60s. I'd like to know if you could comment on those two concepts, the Searle Effects generator and electrogravitics or electrostatic energy fields distorted, used for transportation and so forth. Thank you.
Okay, well, first of all, I get a lot of emails from different inventors, different people who try to use magnetism, gravity to solve the energy crisis, to create a new wave of propulsion systems, and so on and so forth. First of all, I tend to be skeptical of some of these claims. However, that's not to say that they're wrong. I'm simply saying that the ones that I've looked at, you can very easily see where the problem is. For example, magnetic propulsion. Magnetism is quite good to separate North Pole from other North Poles. That's why we have maglev trains that can actually float on a small cushion of magnetism. But magnetism cannot be used to push the magnetic car. It's simply used to make the magnetic car float. For example, if I have large magnetic fields and make them vibrate or move and so on and so forth, what happens is that objects rotate. Compass needles rotate. Iron filings will rotate. They won't have a net motion. they'll simply spin and they'll simply rotate. In fact, that's why we have motors. That's why we have generators. They all spin, and that's ideally suited for magnetic energy. So magnetism ideally is used to make objects spin, and that's why we have hydroelectric dams. That's why we have nuclear power plants. They use the fact that, for example, steam power can be used to make an object spin in a magnetic field, and that can create electricity. However, to use this as a propulsion system would violate the laws of Maxwell. James Clerk Maxwell, in around 1860, around the time of the American Civil War, worked out what are called Maxwell's equations. These are the equations governing electromagnetism. That's how we can build radio and microwave generators without ever having to build a prototype. We have Maxwell's equations. They give us a perfect description of electromagnetic waves. And in Maxwell's equations, at least the equations that we've looked at so far, you cannot use them as a net propulsion system. Magnetism will make objects spin, but not make objects move in a straight line. Okay, let's take a short commercial break, and afterwards I'll talk about anti-gravity. That's a staple of science fiction, but how close are we to harnessing the power of anti-gravity?
Science Fantastic with Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Well, the previous caller asked a lot of questions. I can't possibly answer all of them. And, for example, I have not had a chance to look at the blueprints for some of the designs. However, people have sent me the designs of their particular generator, and I see that they make a mistake. And that is Maxwell's equations, the equations which govern electricity and magnetism, do not allow for a net generation of linear kinetic energy. They make objects spin. And that's why we have electric motors, electric generators. They do not move objects. So that's why, for example, on your bicycle, you have a generator, a little generator that has a magnet which spins, and that's what magnets are good at, spinning. But you cannot use this to generate motion in a linear direction for your bicycle. Okay? Magnetism by itself will not do that. You have to use magnetism to create electricity. And then electricity can be used, for example, in an electric car, to push an object in a linear direction. So you have to go through this intermediate stage of electricity, but magnetism by itself will not make objects move in a straight line. Now, what about anti-gravity? Well, first of all, we have antimatter. Antimatter does exist. We create beams of antimatter at the Large Hadron Collider in Geneva, Switzerland. In fact, when I was in high school, I played with antimatter. Antimatter is naturally given off by certain chemicals like sodium-22. With a cloud chamber, you can actually prove that antimatter is coming out of your radioactive light source and radioactive source. And that's actually what I did when I was in high school, and I went to the National Science Fair with that science experiment. Now, anti-light is light. So there's no such thing as anti-light different from light. Same thing with anti-gravity. Anti-gravity is gravity. Gravity is its own antiparticle. Now, it is possible to counteract the force of gravity using magnetism, and that is the maglev train. However, a hoverboard like we see in the movie Back to the Future, that's awfully hard to do with the magnets we have today. Superconducting magnets, you would have to have a lot of them to create anything that resembles the hoverboard found in the movie Back to the Future. So in other words, anti-gravity is gravity, but you can use magnetism to make objects float and give the appearance of anti-gravity, but it's not really anti-gravity. Anti-gravity is literally the opposite of gravity, and in quantum mechanics, we realize that anti-gravity is ordinary gravity, just like anti-light is light. Okay, well, let's move right along to the next listener phone call.
Hey, this is Jim from Portland, Oregon. My question is this. I read in a book on science that in the fraction of a second after the universe is created, the Big Bang, the universe expanded, I think it was 100 billion miles across. And my question is, if this is true, first of all, is it true? And if it is true, how could it have expanded so much faster than the speed of light? Thank you very much.
Well, you ask a question that a lot of people have puzzled over, and that is, well, the Big Bang expanded very rapidly, in fact, faster than the speed of light. But then people said, but I thought Einstein said that nothing can go faster than the speed of light. Well, not quite. It turns out that nothing can go faster than the speed of light. Yes, nothing is empty space. Empty space can stretch. Empty space can stretch faster than the speed of light. So you see, Einstein is all right. Nothing can go faster than the speed of light. Nothing being space, empty space. Empty space can expand faster than the speed of light. So a more correct formulation of Einstein's famous statement would be that material objects cannot go faster than the speed of light. But empty space is not material. Empty space, of course, is empty. However, empty space is a fabric called space-time continuum, and that fabric can stretch faster than the speed of light. So there's no contradiction with the laws of Albert Einstein. Einstein still has the last laugh when it comes to the ultimate velocity in the universe. Okay, let's move right along to the next listener phone call.
Professor, this is Joe from Akron, Ohio. I once heard that everything around us is made of atoms, everything. So does that mean that everything is living?
Well, the short answer to your question is no. First of all, everything we see around us on the Earth is made out of atoms. In outer space, we have dark matter, which is not made out of atoms, but that's a whole nother story. But the atoms we see around us make up the chemical elements, carbon, oxygen, nitrogen, things like that. And these atoms, in turn, can create DNA. And DNA carries the blueprint of life. So the relationship between atoms and life is atoms can create molecules. One particular molecule is DNA, the famous double helix, that contains information. And cells are bunches of atoms that encircle the DNA, protecting it, and we are made out of cells. These cells have a blueprint and an instruction to go with it, and that instruction is given to us by atoms as well. Well, unfortunately, we run out of time. So once again, you've been listening to Science Fantastic.
This is Science Fantastic. Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries that are revolutionizing our world and touching our lives. And today we're going to talk about one of the most controversial technologies, and that is nuclear energy. On one hand, we have people that say that nuclear energy could be the white knight. That is, if the atmosphere is beginning to warm up, no problem. Uranium does not create carbon dioxide, so let's go nuclear. That's one point of view. Another point of view is, well, take a look at the track record of nuclear power. We had 3 Mile Island in 1979. We had the Fukushima disaster just a few years ago, and we had Chernobyl back in 1986. And nuclear power is on the ropes. The Wall Street Journal is among the most anti-nuclear of the various organizations that are out there because of the fact that costs have soared for nuclear energy. So with us today to perhaps give us a more larger perspective is Tim Judson of the Nuclear Information Resource Service. Website is NIRS.org. And let me be very frank about this. It's very polarized. On one hand, you have the nuclear industry saying that nuclear energy will become so cheap, it'll be too cheap to meter. On the other hand, you're talking to the environmentalists who say that it's an unmitigated disaster. So let's be clear, NIRS is a clearinghouse for anti-nuclear organizations. Later, perhaps we'll have a pro-nuclear organization on Science Fantastic to give a different perspective on the whole subject. But as I said before, in this hour, we're going to take an overview of nuclear energy. First of all, nuclear power plants do not explode like a Hiroshima bomb. Let's get that very clear. In order to have an explosion, you need to have pure uranium, about 90% enriched. 90% pure uranium is what's required in order to get a bomb detonated on, let's say, U-235. However, a commercial nuclear power plant is like a wet firecracker. That is, it uses only 3% enriched nuclear energy, which is enough to create heat, but not enough to create a runaway chain reaction like in Hiroshima. So how do you extract energy from radioactive rock like uranium? Well, when you put it into a reactor, it heats up. 3% enriched uranium will cause it to rise, and it boils water. Water surrounds the nuclear core, and as it boils, the boiling water is shot through a turbine, which spins the blades of a turbine. And the spinning blades turn magnets which then push electrons inside the coil, and bingo, you get electricity coming out. So in other words, it's a very expensive way to heat water. Boiling water creates a thrust of steam. That thrust is then pushed against the blades of a turbine, and the turbine blades in turn create electricity just like in a dam, or for that matter, just like in your bicycle generator. Your bicycle spins, it pushes against a magnet inside your generator, the magnet then spins, and the spinning magnet pushes electrons inside a wire, and bingo, your bicycle light lights up. So in the same way that your bicycle light lights up, nuclear power plants create electricity. Now, what's the problem? Well, there's several potential problems. One is that if you lose the water, then the rods begin to heat up until the rods begin to melt. Now, it's not going to be like the movie China Syndrome, where they talk about melting all the way down to China. It's not going to do that. However, it will cause the containment structure to melt, and the uranium will then go right into the ground, perhaps creating a steam explosion or a hydrogen gas explosion, like what happened at Chernobyl. Back in 1986, we had a hydrogen gas and a steam explosion that blew the lid right off the top of the Chernobyl nuclear power plant, and roughly about a third of the core was lofted into the atmosphere, which became fallout, radioactive fallout, which then sailed over Kiev, sailed over much of Eastern Europe, and even sailed over the United States of America in very tiny form. So we see what could happen in case of a nuclear accident. At 3 Mile Island, it was a simple loss of cooling because of human error. They didn't see the fact that water was draining from the core at 3 Mile Island back in 1979, and the core suffered a meltdown as a consequence. One of the worst, however, was Fukushima, where we had not one, not two, but three melted nuclear power plants whose core liquefied. We've never seen that before, by the way. We've seen cores melt, but we've never seen a 100% liquefaction of 3 cores simultaneously at Fukushima, and the disaster is going to go on for decades. It's estimated that maybe 40 to 50 years worth of agony to begin the process of cleaning up the mess at Fukushima. So with us today once again is Tim Judson of the Nuclear Information Resource Service in Washington, D.C., and we're going to talk about nuclear energy, pros and cons, and we're also going to talk about what the Trump administration has or does not have for the future of nuclear.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again on Science Fantastic, we profile some of the most amazing developments in science and technology that are going to touch our lives. And today we're talking about a very controversial technology. We're going to talk about the future of nuclear energy. For example, what will the Trump administration do given the fact that some people think that nuclear could be the white knight to save us against global warming? Other people think that it's a black hole that'll simply eat up the economy and not deliver on its promises and endanger the population in the process. With us today is Tim Judson of the Nuclear Information Resource Service. Their website, by the way, is nirs.org. And let's face it, in this business, things are polarized. Either you're for or against nuclear energy. And let's be very clear, NIRS.org is a clearinghouse for anti-nuclear information. Later, we'll probably have a pro-nuclear guest on Science Fantastic to give us an opposing point of view. But first of all, Tim, could you explain a little bit how you personally got interested in the nuclear issue and tell us a little bit about NIRS itself?
Sure. Well, thanks, Professor Kaku, for having me on the show. It's really a pleasure to be, to be able to have a chance to speak to you and to talk about these issues.
Mm-hmm.
Well, as you said, my name is Tim Judson, and I'm the executive director at a nonprofit organization called the Nuclear Information and Resource Service. I've been here at NIRS for about 3.5 years. I've been actually, working on issues around sort of public interest policy around nuclear power for about 18 years, and I really got started as a person living in Syracuse, New York, which is near 3 nuclear reactors, concerned about the effects of nuclear power on my local community and the risks that it posed. And there were a number of really significant safety issues occurring at those reactors near Syracuse, the 9 Mile Point and Fitzpatrick reactors, that had a number of people in my community very concerned. And as we began to push for safety improvements and for the closure of those plants, I learned a lot more about the industry and about wide-ranging issues from the impacts of the nuclear fuel chain, from the mining of uranium all the way through to the generation of nuclear waste, and the impacts that nuclear power has on the environment and on local communities, as well as other energy issues, including renewable energy and the potential for the transition to a clean energy economy. NIRS has been around since 1978. We were really founded as an organization to provide people at the state and local level, with reliable, sort of unbiased information about nuclear power and radioactive waste, and to be able to help local communities, deal with the impacts of nuclear power and radioactive waste facilities, on their local environment and their local populations. And so we've been doing that job for 38 or going on 39 years. The relevance of our work has unfortunately remained constant throughout that time.
Okay, well, let's just jump right into some of the controversy around nuclear power. First of all, Indian Point. Right here in New York City, we live in the shadow of a nuclear power plant, and one government study done in 1980 called Crack 2 estimated that a complete meltdown at that reactor, and this is a government study now, would cause property damage up to, if you add up all the details, $300 million in 1980 dollars. So we're talking about potentially billions of dollars in property damage. However, the pro-nuclear people would say that this government study is only a worst-case scenario. But now the Governor Andrew Cuomo, has stepped in and said that he is going to phase out the Indian Point nuclear power plant. So tell us a little bit about Indian Point.
Sure. Well, Indian Point is a reactor site, as you mentioned, that's 25 miles north of New York City on the Hudson River. There's been concern about Indian Point, since the beginning. There are 3 reactors at Indian Point, only 2 of which are still operating. But the first one was opened in about 1961, which was a reactor that was built actually without backup safety systems, and couldn't meet any of the modern licensing and nuclear safety criteria, and was shut down in the 1970s. But the other 2 reactors at Indian Point are much larger and started up after that. And Indian Point is 2 miles from the or 1 mile from the intersection of 2 earthquake fault lines, which wasn't known about when the facility was originally sited. The design of the reactors, the engineering of them wasn't built to withstand the kind of earthquake that can happen around Indian Point. And 17 million people reside or work within 50 miles of Indian Point. And there's really no feasible plan to be able to evacuate that population in the case of a worst-case nuclear accident like Fukushima or Chernobyl. Basically the entirety of New York City is within the 50-mile radius of Indian Point. And for some context as to the relevance of that number, the Obama administration recommended that all Americans within 50 miles of the Fukushima Daiichi nuclear power plant in Japan evacuate, in the wake of the tsunami and natural disaster there, or nuclear disaster there 6 years ago, and so that's is sort of a sense of the scale of the immediate impact of a nuclear power plant accident that can take place. And so a number of public officials, not just the governor of New York, but the attorney general and many local politicians have expressed a lot of concern about the wisdom of having an operating nuclear power plant so close to New York City with so many people that would be at risk. And frankly, given the role that New York City plays, the metro New York area plays within the national and even the global economy, the immense national risk that a nuclear accident at Indian Point could pose. And not just from the potential for a nuclear accident or nuclear meltdown, but the danger of Indian Point would pose as a potential target for malicious activity like a terrorist attack. One of the reasons that the officials in New York really woke up to the danger of Indian Point 16 years ago was that one of the jets that hit the World Trade Center flew directly over Indian Point, and it was later discovered that Indian Point had been considered as a potential target for the terrorist attacks that took place on 9/11.
Now, in case there was a terrorist attack on Indian Point or a meltdown, the population of New York City is, about 8 million or so people. In the greater 8.5 million, and in the greater New York area, you're talking about perhaps double that, maybe like 15 million people if you have a large compass that sweeps the entire area. And that's a good fraction of not just the population of the country, but a good chunk of the economy of the United States as well. So wouldn't a terrorist attack or a meltdown at Indian Point cripple the U.S. economy as well as endangering the lives of tens of millions of people?
That's right, and the risk doesn't just stop there. I think you mentioned the estimate of the economic losses from an accident at Indian Point in the Crack 2 report from 1982. It was actually $300 billion, not $300 million, was the estimate of the damage then. And of course, with inflation and real estate values having increased in the last 35 years since then, the estimates now are potentially $1 trillion or more in economic losses that could occur just from the loss of usable property within the kind of the fallout zone of an accident at Indian Point. But the issue with nuclear power plants in general and Indian Point in particular isn't only from the reactor itself melting down, as we saw happen at Fukushima and Chernobyl. But at nuclear power plant sites in the U.S. in particular, there are pools of water called spent fuel pools where the nuclear fuel that's removed from the reactor is stored on site. And at U.S. reactor sites, and Indian Point is no exception to this, because we have no national solution to the long-term management of nuclear waste, they've continued to store all of that waste on site at reactors in increasingly dense configurations. So at Indian Point, you have two fuel pools that are full of still extraordinarily radioactive and hot, used nuclear fuel that have 5 to 6 times more radioactive material in them than in the reactors themselves. And so an accident involving a fuel pool at Indian Point could have an even greater effect than a meltdown of the reactors. And so you have a sort of a compounded risk that these reactor sites pose. And and when you consider a place like Indian Point, that's you sort of get a sense of the unimaginable scale of what a disaster or a malicious attack on a nuclear plant could entail.
Now, there's a precedent for this in the fact that the Shoreham nuclear power plant in the heart of Long Island was canceled by the governor. And if you take a map of the United States and you see Long Island as this very long piece of real estate coming out of the United States, and you put a nuclear power plant dead center in the middle of that island, you realize that it's impossible. It's just physically impossible to evacuate millions of people across the bottleneck. And then, of course, once you leave the bottleneck, you hit Manhattan. Wouldn't that be the worst nightmare if there was a nuclear accident right there in a place of Long Island?
Sure, that's right. And I think what you mentioned with Shoreham, this was a reactor that was actually built in the 1980s for a cost of in 1986 dollars of over $5 billion. It was a very expensive project, and that site, despite the complete impossibility of evacuating the local population in the case of an accident, that reactor was sited and licensed by the federal government, and it was only stopped by the then Governor Cuomo of New York, and basically required a bailout of the Long Island Lighting Company, the local utility, that the ratepayers are still paying off today. But I think obviously, an act of wisdom on the governor's part to have stopped that reactor before it really started operating. And, the dangers with Indian Point have always been very similar. Indian Point is on the mainland, but in an area that has small roads and is constrained by mountains and, and has traffic, really extreme traffic jams just on a normal afternoon. Never mind, if everybody in Westchester County and the surrounding areas were trying to get out and flee from a nuclear disaster and go to pick up their kids at their schools, and and people that would be stuck and waiting for mass transit to come, all those sort of problems that could occur that people in the local population have really become attuned to.
Okay, now the pro-nuclear people would say yes, 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 but it's not going to happen. So after the break, let's take a short commercial break, and after the break, we'll talk about Fukushima and about whether or not our reliability probabilistic studies are accurate or not to predict a nuclear meltdown.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, we're talking about one of the world's most controversial technologies that's going to come right to the fore because President Donald Trump wants to rearrange our energy priorities. So with us today is Tim Judson of NIRS, Nuclear Information Resource Service, and you can go to their website at nirs.org. And later on, perhaps we'll have another guest who will talk about a more pro-nuclear point of view. So, Tim, tell us about Fukushima. Why were the Japanese caught off guard? Didn't they plan for it? I mean, nuclear power plants, of course, are relatively safe. A day goes by and nothing much happens at a nuclear power plant. But what happened at Fukushima?
Sure. Well, I think the thing to kind of keep in mind about nuclear and power in general is that, from the beginning, there's been a deep recognition that operating a nuclear reactor poses a significant safety risk. And, even in the 1950s, as the U.S. government was beginning to promote nuclear power both here and abroad, they had to address some very sticky questions about that. And one of them, obviously, was the risk of a nuclear accident and the kind of damage that could impose. And so what the U.S. did from the very start was pass a piece of legislation called the Price-Anderson Act, which essentially has been a law that's been in place for 60 years now, that limits the liability of nuclear power corporations that own and operate reactors from the financial liabilities that they would face from a nuclear accident. Essentially, it sort of caps the industry's liability at currently about $13 billion, but essentially commits the federal government to pay for the damages and liabilities that exceed that. And in Japan, at Fukushima, you kind of see what the scale of that could be. We've talked about Indian Point, where upwards of $1 trillion for an accident at Indian Point would be the impact. At Fukushima, the estimates early on about the cost of the damage from the cost of recovering from the accident. We're in the many tens of billions of dollars. The government released an updated cost estimate in December that the cost of the cleanup and recovery from the Fukushima disaster is going to be at least $188 billion now. And so this is a risk that is well known within the industry that is quite significant, but that is generally a risk that's going to be borne by the public because the industry could never obtain a level of insurance that they could buy for themselves to absorb the impact of an accident. So in Fukushima, what happened, was the other thing to remember about nuclear power is that because of the enormity of the risk that's entailed, reactors are supposed to be designed with redundant safety systems, to high degrees of engineering expertise and precision, to be able to account for and operate safely on a daily basis. But because of the nature of the technology, when things go wrong, things can go very, very wrong. And that's where problems with the wisdom and the interests of the regulators and the government and the industry can really be at cross purposes with nuclear safety. And so in Japan, obviously Japan is well known to be a region subject to a lot of potential for natural disasters, from volcano eruptions to earthquakes. Engineering standards for buildings in Japan are among the highest in the world because of the frequency of large earthquakes there. And people in Japan had been raising concerns about the vulnerability of nuclear power plants to earthquakes for decades. But the government essentially, at the behest of the utilities, which had invested many billions of dollars in building and operating their nuclear reactors, essentially, spent more effort assuring the public that things were safe than in actually taking safety precautions. And so what happened at Fukushima was entirely predictable, but the government had ignored the risk and had not made the industry take measures that would have been necessary to mitigate the risk. So what happened at Fukushima was, obviously there was a large 9.0 on the Richter scale earthquake on March 11th, 2011, that shook the site, but actually wasn't the cause of the nuclear disaster. What happened was... Okay,
Tim, we're going to have to take a short commercial break. And after the break, we're going to get into the autopsy of what happened at Fukushima, blow by blow. And what's next for 3, not 1, not 2, but 3 melted nuclear power reactors.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about perhaps one of the most controversial technologies of modern times. We're talking about nuclear energy, its past, its present, and its future. With us today is Tim Judson of NIRS, Nuclear Information Resource Service. Their website is nirs.org. And where we last left off, we were just beginning to talk about the Fukushima disaster, where a tsunami overwhelmed the safety systems of these nuclear power plants, causing three nuclear power plants to melt down. A 100% melt in all 3 reactors, a liquefaction process that we've never seen before at a commercial nuclear power plant. And what is the status of the cleanup? First, you have to stabilize the system by getting the cooling water to circulate. Then you have to remove the melted core. But, Tim, how far are we in this process? Aren't we really at the very early stages of stabilizing the reactor accident?
Yeah, it's hard to really say whether we're even at the beginning of a true cleanup and recovery at Fukushima. We're 6 years past the accident. Only really one thing of significance has been done since the accident happened, and that was the removal of irradiated fuel from the fuel pool at the number 4 reactor. on the site, which happened about 2.5 to 3 years ago. But in terms of the three, just to give a little bit of background on the site, Fukushima Daiichi is actually a 6-reactor site. But at the time of the accident, only 3 of those reactors were operating. The other 3 were shut down for refueling. And so all 3 of the reactors that were operating melted down. The 4th reactor, had been shut down, and the freshly removed fuel was in the pool, and so still very hot. And there was a danger, and there was a really strong concern in the weeks after the accident that there could have been a loss of water in the pool at Unit 4, and that fuel could catch fire and create an even bigger disaster. Luckily you saw the images in the weeks after the disaster, or days after the disaster, where they were pumping as much water as they could, pumping and dumping as much water as they could into the pool of that reactor to try to prevent that from happening. The easiest thing they've been able to do so far, which wasn't easy at all because the building was so damaged, was to get that fuel out of the pool at Unit 4 before the building was in danger of collapsing, and to move it into another storage site on the ground. But as far as the 3 reactors that melted down, there's been virtually no meaningful recovery of those sites at all. In fact, the owner of the plant, Tokyo Electric Power Company, or TEPCO, still does not know where the fuel that melted out of the reactors is on site. There are some indications this week that they may have gotten a camera in that identified where some of the melted fuel might be in the number 2 reactor, but they haven't even been able to get a robot in close enough to be able to tell whether that's actually the nuclear fuel or something else. Essentially, inside the reactors, where these accidents took place, the radiation fields are so powerful that every time they've sent in a robot to try to inspect, the robot's electronics have been fried out by the radiation fields, and they haven't even been able to determine the status of the internals of the reactor well enough to even begin planning a cleanup of the site. Now, this is compounded by the fact that Fukushima, the nuclear plant, is obviously right next to the ocean, but but because Japan is mountainous, there's a lot of water that flows down from the mountains through the in the groundwater of the reactor site. And so for the last 6 years, there's been about 300 tons of water a day.
Tim, we're going to have to take another short commercial break, and after the break, we're going to continue with the discussion of the horrible mess at Fukushima.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, we're talking about the future of nuclear energy. With us today is Tim Judson of the Nuclear Information Resource Service, NIRS.org is their website. And we just finished a discussion of Fukushima. And I should also point out that the United States Pentagon has gotten interested in this. They set up a DARPA challenge, challenging the robot specialists around the world to create a robot that could clean up the mess at Fukushima. All it had to do was get into a car, sweep the floor, turn a few valves, and do things that even a child could do. And the results were horrible. Only one entry was able to finish the required goals of the challenge, and it basically showed you that, well, robots are not going to be able to clean up a mess like at Fukushima anytime soon. Well, let's move on, because I want to talk a little bit about the arguments of the pro-nuclear side, and they say, yes, nuclear power plants are potentially dangerous, but we're getting better at handling nuclear accidents. But what about global warming? After all, just look outside. The weather seems to be changing. Even farmers know that. Summertime is about a week longer than it used to be. Every farmer knows that. So the question is nuclear the white knight? So, Tim, what are your thoughts?
Well, global warming is obviously, one of the greatest problems that humanity faces at this point. I mean, whether you believe that human activity is the sole cause of it, the scientific consensus, among more than 99% of the scientists that study the issues, is that human activity is contributing to global warming, and that we need to take measures to reduce the amount of carbon dioxide and other greenhouse gases that we're emitting into the atmosphere. And so, given a problem of this scale, we have to be practical about how we're going to approach solving it. And the reality, and so we clearly need to transition to non-CO2, non-carbon dioxide emitting energy sources. And so this is a space in which the nuclear industry has really tried to promote itself, as a source of electricity that can generate without the direct burning of fossil fuels. The problem that we have is that we have to look at, what's going to be a practical way of addressing the problem. And that means, technologies that can be deployed quickly enough at an affordable enough cost, that we can actually reduce emissions quickly enough to mitigate the impacts of global warming. And nuclear power fails those tests. The reality is that nuclear power has proved to be too expensive and too slow and too unpredictable to be able to provide, reductions in greenhouse gas emissions and fossil fuel use in any meaningful way. So, for instance, there was a report out this week from The Economist magazine that showed that of the 55 nuclear reactors that are being built in the world right now, 35 of them are years behind schedule. And I think if you looked at it, most of those would also be way over budget. And, when energy analysts compare the costs of different sources of energy, nuclear power is by far the most unattractive option available. And in fact, Wall Street investment firms declared years ago that any energy company that decides to invest in building new nuclear power plants was going to be downgraded, and in some cases near to junk investment grade for taking on such an unwise risk. Now, by contrast, we've seen the cost of renewable energy sources and energy efficiency, falling at astronomical levels. That the cost of solar power is now 5 times less than what it was, just 5 or 6 years ago. And the same thing has happened with wind energy, and energy efficiency is by far the cheapest energy resource that we have. And so, what we really see happening is that, both just in terms of how rapidly and how quickly and how affordably renewable energy and energy efficiency can be deployed, we could actually, have a much better chance of dealing with the climate, crisis with a transition to renewable energy sources than we can, with investments in nuclear energy. And this is becoming an increasingly, sort of immediate issue, because at the same time that building new nuclear power plants has proved to be a total failure in the U.S. and elsewhere, the existing nuclear reactors that we have in the country are getting so old and needing so many upgrades and repairs in order to be able to continue operating, or or to even be operating safely. That the cost of them has gotten so great that the reactors are closing just because they're simply uneconomical to operate. And so, we're facing a situation in a number of states, including New York, where the choice is really before us. Are we going to, invest billions of dollars in subsidies and bailouts to prop up the existing, group of nuclear reactors, or are we going to put our eggs in the basket of renewable energy? And I think when you see the evidence of what the costs are for these different energy sources and the number of jobs that can be created in transitioning to cleaner energy sources, from our standpoint, the conclusion is pretty clear that we ought to be investing in modernizing our infrastructure and in moving to cleaner energy sources, and not in propping up nuclear power or trying to build new nuclear reactors.
Okay, well, even though the Trump administration does not have a complete, detailed overall energy strategy, what is your thinking? You're in Washington. What is your thinking about what the Trump administration will do with regards to nuclear?
Sure. Well, the Trump administration seems to be very clear that that the environmental impacts of energy sources are not going to be, a consideration for them in determining energy policy. And so, there's been rumors since Trump was elected that he is going to pull out of the United Nations climate agreement that the U.S. signed on to a year ago, and that climate change is not going to be a factor in their decision making. So,
wrapping up, we have to wrap up. So, has the Trump administration given us any indication as to what his nuclear policy will be? Yes or no?
Yeah, so Trump has been known to be pro-nuclear for a long time. One of our